Hello, my dear children. In your studies, writing the classwork notes is also an important part. Okay, my dear children. So, while you are writing the classwork notes, follow this format. In your classwork notes, write this format. See here, index at the first page. Okay, my dear children. Page here, right here index, here serial number. Okay, my children, here serial number. Second one, here name of the chapter, name of the chapter. Next, here after name of the chapter, see here from page number, from page number. In this column write here from page number. In the next column, to the page number, from this page number to this page number, this chapter is written. Okay, my children, after completing the chapter, you have to get the sign of the teacher. You have to follow this format while you are writing the classwork notes. For getting internal marks, we have to maintain a neat classwork notes as well as homework notes. Understood, my dear children? Right. Hello, my dear children. See, number systems. Exercise 1.1. We have discussed the points related to exercise 1.1. The definitions, important points we have already discussed. Now we are going to start problems in exercise 1.1. See page number 5 in the textbook, page number 5, question number 1. First question. See question number 1. Is 0 a rational number? Is 0 a rational number? Can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Understood the question, my dear children? Here they are asking 0. Is 0 a rational number? Means we have to remember, recollect the definition of rational number. Means we have to write a rational number, a number which is in the form of P by Q. Do you know this one? Yes. Okay, my dear children. This is the question. Okay, understood, my dear children? Right. Now come to the solution part of this question. Yes. For this question, we can say yes. Why we can say yes? See here, 0. 0 can be written as 0 by 1, 0 by 2, that is equal to 0 by 3, that is equal to 0 by minus 1, 0 by minus 2, and so on. We can write here 0 as 0 by 1, 0 by 2, 0 by 3, that is equal to 0 by minus 1, 0 by minus 2, and so on. Okay, my dear children. Here numerator is integer and denominator is also an integer, and moreover denominator is not equal to 0. Numerator is 0 but denominator is not equal to 0. See, observe here, denominators are integers, non-zero integers. Okay, my dear children? Right. Now come to the question number 2 in the exercise 1.1. Find 6 rational numbers between 3 and 4. Understood, my dear children? Between the numbers 3 and 4, we have to write, we have to find 6 rational numbers. We have already learnt that there are infinitely many rational numbers between any two rational numbers. Do you remember that point, my dear children? Yes. Now we are going to write we are going to find only 6 rational numbers between these two rational numbers. Is this rational number or not? Yes, because 3 can be written as 3 by 1. Similarly here 4 is also a rational number. Okay my children, this is also in the form of P by Q, 4 by 1. Understood the question my dear children? Right. Now come to the solution part. Let us write the given numbers first. What are the given numbers here? 3, 3, and what is the second number? 4. Okay my dear children? 4. What I said here, 3 can be written as 3 by 1 and 4 can be written as 4 by 1. Understood my dear children? Now if we observe, these two numbers are fractions, isn't it or not? Numerator is 3, denominator is 1. Here numerator is 4 and denominator is 1. Now before writing the 6 rational numbers, first of all we have to check whether the given two fractions, given two rational numbers are like fractions or not. Do you remember the definition of like fractions? Yes. If the fractions are having the same denominator, then the fractions are said to be like fractions. In these two fractions, what are the denominators here? Here denominator is 1, here also denominator is 1. So both are like fractions. So first of all we have to check the given rational numbers are like fractions or not. If not, we have to convert them into like fractions. Means we have to make their denominators same. Understood my dear children? Right. So here this part is over. They are like fractions. Now come to the question. How many rational numbers are required here? 6 rational numbers. Let us consider the required rational numbers is n. Let the number of required rational numbers, let the number of required rational numbers is equal to n, that is equal to here 6. Isn't it? How many rational numbers are required here? 6. So here 6. Now we have to find the value of n plus 1. What is n here? 6. So what is the value of n plus 1? I mean 6 plus 1. What do you get here? 7. Isn't it or not? So here multiply this numerator and denominator by 7. So 3 by 1 is the number. So 3 into 7 by 1 into 7. Understood my dear children? Why we are multiplying by 7? Here the required rational number is 6. So we have to find out n plus 1. By that number we have to multiply the given rational numbers, numerator and denominator, by that n plus 1. Okay my dear children? Now 21 by 7. So we converted 3 by 1 in the form 21 by 7. Next take the second number 4 by 1. 4 by 1. Here also we have to multiply numerator and denominator by 7. Same number. So 4 sevens 28 by denominator 7. Here also the rational number 4 by 1 is written as 28 by 7. Understood this question my dear children? So in between these two rational numbers 21 by 7 and 28 by 7. We can find out easily the required 6 rational numbers. Okay, my children, right here by 7. Required rational numbers. Required rational numbers. Okay, my children. See here, how many rational numbers are required here? Yes, 6 rational numbers we have to write, isn't it? Now we are going to write the 6 rational numbers. Okay, my children. See here, we are going to write. Now we are going to write 6 rational numbers. Yes, now we write the required rational numbers. How many rational numbers are required here? 6. So here a simple technique. Right here 6 rational numbers with the denominator 7. Here denominators are 7. So denominator 7, denominator 7, denominator 7, denominator 7. How many rational numbers I wrote here? 1, 2, 3, 4, 5 and one more rational number. 6. Total 6 rational numbers I wrote here. But I did not fill the numerator. I wrote only denominators. Isn't it, my dear children? Yes. Now come to numerators here. 21 is there. Here 28. Just write numerators. 21 after, what is the 21 after number? 22. So 22 by 7. Next to 23. Next to 24. Write 25. And 26, 27. Just to write the numbers, counting numbers in the numerator. I wrote here first 22, after 21, here 21 is there. So 22, 23, 24, 25, 26, 27. On the whole, if you observe, 22 by 7 is a one rational number, 23 by 7 is one rational number, 24 by 7 is a rational number, 25 by 7 is a rational number, 26 by 7 is a rational number, and 27 by 7 is a rational. How many rational numbers we wrote here? 6 rational numbers. These are the 6 rational numbers between the given two numbers 3 and 4. Understood, my dear children? Right. So, my dear children, while you are writing, while you are finding the required rational numbers between the given two rational numbers, follow these steps. I will repeat the steps. What are the steps to be followed? First of all, we have to convert the given two fractions as like fractions if they are not like fractions. If the given two fractions or if the given two rational numbers are not like fractions, first of all we have to make them as irrational numbers with the denominators same, like fractions. We have to make them as like fractions. In this question already they are like fractions because denominators are same. That is the first step after converting them into like fractions. We have to write this step. What is the step? The required rational numbers. In this question n is equal to 6. Okay, my children. So we have to find out n plus 1. We have to find the value of n plus 1. That is important number to find the required rational numbers. By that number, we have to multiply numerator and denominator of the given two rational numbers. Okay, my children, like this we are getting two rational numbers like this with the same denominator. After that, write denominator with the denominator, same denominator, write how many rational numbers are required without numerators. Leave it. Okay, leave the numerator part empty, keep it as empty place, empty space. Only write the denominators with the denominator. How many? 6 rational numbers are there, so write here 6 rational numbers with the same denominator. Okay, my children. After that, in the numerator part, we have to write the numbers between these two numbers, between the given two numerators. 21 is here, 28 here. Between 21 and 28, I wrote here, see there, 22, 23, 24, 25, 26, 27. Understood, my dear children? Okay. Do you complete the next question? Oh, my dear children, right. Now come to the question number 4. See here, question number 4. State whether the following statements are true or false. Okay, my dear children, here true or false statements are given. Now give reasons for your answers. Okay, my dear children, understood the question? We have to write either true or false, and we have to write the answer. For that answer, we have to give the reason. Okay, my dear children. Now come to the first question, first statement. Every natural number is a whole number. Every natural number is a whole number. Isn't right or true or false statement? Yes, it is a true statement. Since the collection of whole numbers, contain all the natural numbers, that is why the given statement is true. So I am writing here solution. Yes, it is a true statement. It is a true statement since the collection of, this is the reason. Since the collection of whole numbers contains all natural numbers. Contains all the natural numbers. The whole numbers, all the natural numbers are also included. Understood, my dear children? Right. Now come to the second statement. See the second statement. Every integer is a whole number. Is this a statement true or false? It is a false statement. Okay, my dear children? It is a false statement. Every integer is not a whole number, but every whole number is a integer, because there are negative numbers are there, but in whole numbers there are no negative numbers. For example, -1 is an integer, but it is not a whole number. -1 is an integer, but not a whole number. minus 1 is an integer, but it is not a whole number. That is why the given statement is false. Understood, my children? Right. Now come to the third statement. See the third statement. Every rational number is a whole number. This is a given statement. Is it a true statement or false statement? It is a false statement. It is a false, because every rational number is not a whole number. For example, minus 2 is a rational number. It is a rational number. Is a, for example, minus 2 is a rational number, but not a whole number. Understood, my children? Right.